Here we go. Yes. Oh, and I need to change my view. That's right. Okay, cool. Here we go. Hello, everyone, and welcome to our January 2022 Jupyter Community Call. This is the first one of the year. Woohoo! I'm cheering for all of you because y'all are being polite and being on mute, but I'm seeing some cheers in the background. So excitement for that. A few things before we get started, my usual things, in fact. This is a Jupyter community gathering, so we are all held to the Jupyter Code of Conduct while you're here. That can be found at absolutely any time at jupyter.org/conduct. And additionally, I am recording this call. It will be posted publicly, whatever that means for you. There's your heads up. And from there on out, I think we're good to get started. If anyone hasn't been here before or just needs a refresher, what we're going to do is follow the agenda that I've linked in the chat. So we're just going to go through short reports, then longer shares, and with probably plenty of time for discussion. But I am so excited. We have lots of things on the agenda today. So yes, and that's what we're going to do. The first thing we have is a shout out from Zach. Would you like to take it away, Zach?
Yeah. Hey, everybody. Zach Saylor here. My shout out is to Isabella because we're starting a new year and she just ran the community calls for a whole year this last 2021. And these are awesome. I know I ran these for 6 months and they are horrifying because you never know if people are going to show up. And so congratulations, Isabella. Great year. Thank you for running these. You do such an amazing job.
Thank you. That's really sweet. And that means a lot coming from you. I appreciate it. And yeah, Tony, thanks for linking the blog post. Tony mostly wrote this, but it was a really good discussion of kind of some of the things that we did to make it consistent, because I think that's a struggle with any meeting, not just community calls. So he did a really good job summarizing that, and then I added bullet points. So yeah. That is the only thing currently on the short reports, but did that inspire anyone else to celebrate something? New Year is a great time to celebrate.
Oh, what? Let's see how red we can get Isabella. I want to give a shout out to Isabella for organizing the accessibility workshops the past 2 weeks. This weekend, we probably got like nearly a dozen contributors in on documentation. We had a great talk the week prior, so there'll be some assets coming up from that. So another shout out to Isabella. Happy New Year.
Thanks. Yeah, that was another set of events. I'm glad that the first 2 are done. We do have 2 more coming up in March, just as a little follow-up for that. But yeah, it was awesome. Those PRs will be in the works at the end of this week because we're giving contributors time to polish up if they want outside of the rushing sprint environment. First, any more celebrations, shout outs, quick things? We had a release on this project and I'm super proud of it. Those kind of things.
I have one. Want to shout out to Zach for being an early adopter of the new governance process and setting up the Jupyter server team. We're all really excited to be a part of that. So thanks, Zach. You're doing a great job leading us into the future. That's it.
Fantastic.
I think we got to give a shout out to Darian for going around and making sure that everybody's aware of the new governance process changes. He has to be in so many meetings voluntarily during the week that God bless his soul for doing that. And we hope to follow suit with what Zach's done very soon.
Yeah, I agree. Darian has done at least in meetings I've been in, done a great job pulling apart the document into steps to take. I really do appreciate it.
Do we say congrats to the Binder team for not letting Binder fall over too?
If you want to, I mean, I think that's important.
That was another thing that happened this month. Congrats to Binder for keeping that alive. I don't know what I'd do without that, but good for y'all for sorting out all of those credits on
that was like minute. That was big shout out to Chris Holdcraft for organizing at least a set of short-term credits, and another one to Min, who works on the technical side to reduce the monthly cost so that short-term credits are actually viable.
Yeah, I know so many people that use that, so very grateful that kept running. Thank you all for your various tech and money gymnastics is what I'm hearing. More celebrations? We still have time. Going once?
I'll call out a tweet from Chris Holgraff. He showed a pretty sweet demo of, or GIF, I don't know how to pronounce it, of I think a mist parser in Jupyter Lab notebooks, which I thought was really cool. If we can get
I hope Chris Sewell's here to show us that.
I'm demoing that today. Don't worry.
Oh, great.
Oh, yay!
It's on the docket. It's on the docket.
To set the bar this high, you better perform.
Oh, don't you worry. I wrote it all. I know it.
That's
Finally
awesome,
writing
a preview.
You've been converting code into Python from JavaScript, and now you finally have to write JavaScript. Congratulations on going full circle, Chris.
I know, it's a snake eating its tail kind of situation, isn't it? Scary.
Wonderful. I will be quiet for a few more seconds. I love all these celebrations. It's a great way. I don't know about y'all. It's a great way to start my year. Yeah.
One last one. Let's celebrate everybody being here. And then we
Okay.
move on. Yes.
That sounds
Thank you all
wonderful.
for being here.
Right, that's true. Zach made the point that it's hard to keep these running, but they really wouldn't be runnable without all of you. As absolutely cliche and cheesy as it sounds, it's very, very true. If I just sat here alone, it wouldn't really be a community call, so I appreciate it. And great. Oh, those were so wonderful. I'm definitely going to revisit this recording this part later. Thank you everyone for the joy. And with that, we will take it away with all the agenda items. We have a couple today, which always makes me happy. I think the first one is, I apologize, but so tell me how to pronounce your name properly. Jitendra?
Yeah, that's right.
Okay. Are you ready to share?
Yeah, so how much time I got?
We have for sure 2 things on the agenda. I'm checking to see, there's one person who said they might be on the call, but I'm not seeing them here. So I think you have at least 15 minutes.
Okay.
Let's try and keep it at 10. Let's try and shoot for
10.
presentation
Okay.
at 10. And
Okay.
then questions with a little extra, and we'll see if we can make some time.
Okay.
Yeah.
Sounds good. All right, I'll share my screen. All right. Here I want to talk about. Okay. So by the way, I'm Jitendra Pandey. So we have this small company called Infant Store. It's a startup in the ML ops space. So I'm a co-founder and CTO, and our CEO is also on the call, Jagan. So we recently built this MLflow kernel. This is basically an extension of the IPython kernel. And the motivation is that to have an integration with MLflow, which is becoming very popular in the MLOps space, to make sure that when whatever activity you are doing in Jupyter gets recorded in the MLflow in a very seamless way. So MLflow has integrations with a lot of libraries like TensorFlow or XGBoost or in fact most of them, and when you can enable auto logging, it will log certain parameters and matrix and all and whatever you want to record. But there are certain additional things like, okay, in the cell, whatever output cell produced, or what was the exact code that was executed in the cell. Those things are not captured in an auto log. So for that, we need a kernel that can actually intercept and send it to MLflow for recording. So that is what I want to present today, and I'll show you a short demo. So MLflow kernel can record all the cell outputs, which includes like if you have any graphs or images that you are using to visualize your data. All that is captured and recorded into ML as an MLflow artifact. I'm hoping that you guys are somewhat familiar with MLflow, but I will show you an interface so that you have a mental image of what I'm talking about. So and also the organization of your Jupyter notebook execution. Like typically you start a kernel and then you have you execute it cell by cell. So all that is captured in a very well organized fashion. Like the duration of a kernel session is recorded in a parent run, and all the cell executions within that are recorded as child runs. And as I mentioned, that it integrates with the auto logging. So all your like if you are say recording the model in MLflow, or you're recording matrix, so that all is captured in the same place along with your cell outputs. So if time permits, I will show you a demo of the deployment. Otherwise, I'll come back to this slide and show you the steps. In short, this is my contact. So if anytime you can shoot me a message. All right, so let's head back to the demo part. All right, so I recorded this so that I'm in control of the time, and also because training takes a little longer, so to make sure it fits within the time frame. So this is a typical notebook. I got this code from Kaggle. Essentially, it's a facial landmark detection. Basically, you have a face, and this code can train a model to detect the location of the nose or eyes or lips on the face. It uses a convolutional network, and it has a hand annotated training data, which I will visualize shortly. So as I mentioned, yeah, this is implemented in Keras, a very simple model. And I don't claim that it's the best model out there, but it does a decent job. Like there are a few cells, we load the data, we do some analysis and some certain augmentations, and at the end of it, yeah, split into training and test and perform the training here. So, and in here, like during the training phase, we also enable autolog to showcase that that MLflow behind the scene will capture everything along with the parameters that the code wants to launch. But you don't have to worry about starting a run or stopping a run or anything. All that is taken care of, and all your code is also preserved. So we first pick the kernel. So MLflow kernel is an extension of IPython kernel. So actual execution is all happening in IPython. We are just a layer that captures. And by the way, this code is all in open source. GitHub link is also available. So this is a interface for our MLflow. This is MLflow's free service that InfinStore offers. So you can sign up anytime. I will give you a link for that also. And this MLflow kernel in this notebook is already configured to talk to that MLflow service. So we have started a run. First run will take a few seconds. It has to connect to the MLflow service and start the runs. And now we are loading the data, and it will also produce some output. And then we do some further analysis and a little bit of augmentation of the data. So so yeah, so this execution, now here we are visualizing the data. We can see that what data looks like. In the data, we have some hand annotations of the location of the landmarks like eyes or nose tips. So now let's see what we have achieved in the MLflow. So here MLflow shows that we got a run started. There are 4 cells executed. So we have 4 individual runs already captured here. If you click on the last one, you see that the cell output is captured, the code is captured. So this record is forever. If you go and modify, rerun it, that will be a new run. So you can always go back to what was run, and even your visualization history is available so that you can go back in time and see that, okay, what really happened in that cell. Yeah. So now we go back, go to the training. So here we will first do the splitting of testing and training data, and then we launch the training. So training will take a few seconds. Actually, in real, it takes a little longer, but I have expedited it and using only one epoch. So the purpose was to show the MLflow integration part, not really the accuracy of the model. So training done. Now it is logging the model to MLflow. It is also going to the same MLflow service, and that plumbing is taken care of. And in the end, we do a little bit of, prediction on certain images. So, and the prediction output is also displayed as an image, and this is what data scientists typically do. They visualize the data, and now we have we can see that. Okay, so we got logged out, but we can log in back. This is MLflow service. It is secure, so password authenticated and everything encrypted. So in here, the last but one run had the model training. So in this one, we can see that we have captured a lot of information. So some of the information has come from auto logging, some of the information has come from logging the model itself. And so here is the code. So we keep tweaking the models, but at every step, this is how we preserve the code. And any standard output, if the user is interested, is also captured, and all the details of the model are captured, including the dependencies. So, if there are a lot of parameters to be tuned, and capturing those parameters is always helpful, and everything is going into the same run. So the record of everything is in one place. The metrics are also captured depending on how the framework has logged the matrix. And we can also look at the maybe model summary. That how my, yes. I've talked about the matrix already. So this is basically MLflow integrated with a Jupyter kernel. And so this is the visualization of the model output. This is very key because user data scientist wants to go back in time. How my model did, and look at it visually. If you had plotted some graphs here, all those that will be visible. Those images will be available here to always review what your model did in past. So in here, so Jupyter Notebook execution is done. One last thing that I wanted to show was for those who are not that familiar with MLflow, that you can manage your model here also, because now if you register this model, it will be registered in the MLflow service. We can store this model as a version of an existing model, or create a new model and go to that version and manage the life cycle of the model. Like you can designate it as in production or staging, or it is an archived model. So typically we create a new version and old versions are archived. We have all the permission controls here also, like you can authorize people to access this model. And this is how we transition the state. And this is linked to the run. So you can always click on the run and go back to see that what was the code inside, what was and all the outputs that I showed previously. All right, so this brings me to the end of this presentation. For the deployment, I have another short clip. I can show that how do we really deploy it, and the login and authorization part as well. But any questions here, I would love to answer.
I actually have one if no one else does. Okay. So maybe I'm missing something, but I wanted to ask you, it sounds like a lot of this is for recording, right? All the parameters that got you the result that it did. But then if you wanted to reproduce that, is that something you'd have to do manually, recreating all these parameters? Or is that kind of what you were talking about with the register model, that creates some way for you to automatically set that up again?
Okay, so the integration of MLflow kernel is with the notebook. So every time you execute the notebook cells, it is captured. So if you are reproducing, suppose you want to go back in time, reproduce something, and at that time it was a different code, then will be a step that you go to that run, take that code and paste it into the Jupyter notebook. But that's a good idea. Maybe that could be a feature for the future, that we somehow provide an easy way to click and rerun.
Stitch a notebook, maybe stitch a notebook from all the different child runs. That's very interesting, actually.
And actually, I mean, as a company, we have a compute feature in our product where we capture these notebook code as what we call as transformations. And there you have the ability to actually go back to a transformation and click a button and it will execute. But probably some other day we will showcase. It will be a longer presentation. So. But yeah, throw questions at me. Feel free, interrupt me anytime. I would just want to show how to deploy it because visually it will be a lot more interesting. So this is our, and I want to show particularly like how we deploy it with our free InfinStore service. So this is how you sign up for the service. It's a one small page. You need to provide an artifact location where all the output will be stored, and you can specify an IAM role for authentication and authorization. But I have already created this account here, and in which we will do the logging. All this UI is a standard ML flow, but we have a more scalable enterprise backend. So you can create a new experiment or use an existing experiment when you are configuring your MLflow kernel. So let me create a new experiment so that.
Does your kernel let folks do all of this programmatically?
So this is at the. So there are two pieces to it. One is the kernel itself. Another is the MLflow service. So what I'm showing right now is MLflow service, which you'll have to set up. And once you install the kernel, then rest of it will be automated.
Okay.
So we have, it's a PyPy package. We have installed MLflow kernel right now, that version number 110, but the version numbers are rapidly changing. So second step is to actually add this to the kernel spec. Okay, so right now we have Python kernel, but let's add MLflow kernel in the spec. And this another step will create the, add that to the spec. And that is it. We have to now put some configuration. So configuration location is in the .jupyter directory itself. It's a JSON file, and we need only a few parameters there. So we need an MLflow tracking URL, basically and it could be InfinStore's MLflow service or any other MLflow service. If you have, you can use anything there. Debug enabled is useful. And you specify your experiment name. So we just now created this phase research. So let's put that there so that all the runs are created in that lane. And now we start the Jupyter lab.
So the really cool thing about this, and the first thing that occurred to me was, often data scientists go back to the same cell, tweak something and rerun it, and tweak something and rerun it. Every run of that is captured. So you can really go back and look at it and say, okay, fiddling with this, fiddling with that, here's what I really found useful. That I find very valuable. I mean, the notebook itself is a pretty awesome structure, and it saves the final state of what you end up with. But this, Jitendra's invention, basically records every activity you take, and I find that really cool.
So we selected MLflow kernel because now it was in the kernel spec. So when you are doing it for the first time with MLflow service, you will need to log in. So it will prompt you for this small piece of code here, which you just need to log in. We will use the same account password that I showed on the UI that you will create when you are signing up for the service. If you have your own MLflow service which does not need this step, then this won't be prompted. So once the login is done, you don't have to do it again. It will be automatically refreshed. We can get rid of that login code and we restart the kernel. Now at this point, it is ready to use. We again, and the rest of it is what I showed in my previous demo. So Now we start the run and we go back to CML flow, and we should see a run in this new experiment that we created. And you see that it was just an import code, but the code is captured and everything as expected. So that brings me to the end of my presentation. Thank you so much, but feel free, shoot me a question anytime, or
There's a question in the chat. If all the cell source is Python, would it be possible to implement these features as a shell extension instead of kernel?
Okay, so okay, that should be possible because it's a standard kernel. So all the kernel APIs are supported. I have not played with that, but the MLflow kernel is created implemented is just an extension of IPython. Whatever it does not understand, it delegates to IPython kernel and just hooks up with the MLflow service in the middle. So that should be technically possible. All right. Yeah. One last thing to mention that we do have SageMaker integration also. If some users are using SageMaker, the steps are available on GitHub and also on our website, or just drop me a note and we will help you set up. We have created an image with MLflow kernel enabled, which you can actually directly use to get your SageMaker studio up and running with MLflow kernel. But if you are using just stock Jupyter from open source, those steps, which are also highlighted here, will completely suffice.
Wonderful. Any more questions? Okay, then. Well, thank you for such an in-depth share. I always like to see what people are working on, and saving all these different versions seems like it could be really helpful, right? Recording is the first step for knowing what you're doing. So thank you so much.
Thank you.
And then next on our agenda, if I can read the agenda, is we have demo. I'm assuming this is from Chris based on what happened during the announcements earlier. The demo of...
Hey, yeah.
Okay.
Yes. Why not? Yeah, I've just been messing around with it. Let me share my screen.
Did the NAAS folks not show up?
I was going to check it then, but I don't see the person who said that they would be here. So
Cool.
I was just going to check again. But if that's not true, let me know at any point. Sorry. Thank you, Chris.
That's not the right screen. Or is it? I'm confused. Yeah, that's the one. Oh, no, yeah, you can see the VS Code.
Yes, that's what I'm seeing. Okay,
Cool. Yeah, I thought I'd give a quick demo. I've just been throwing together a bunch of stuff over the last few months in the executable books world. So trying to pull it all together here. So yeah, these are the kind of 6 things of our time to fill the rest of the space time is writing notebooks with this text-based markdown format. Then how you can use that with VS Code, how you can also use that in Jupyter Lab, and also some extra things of how you can execute these notebooks and feed them into creative documentation with MistMB and JupyterBook. So Mist is essentially this format that we put together over executable books project designed to extend the common mark, which is the common markdown specification, with more of advanced features for writing richer documentation, scientific articles and the like, admonitions, figures, tables, etc. It's what we use within JupyterBook to generate these documentation, the books and websites. So we want rich documentation, but also we'd like to be able to hook into Jupyter, as the name suggests, and execute some code. So what is missed, one of the main things it adds is these role syntax and the directive syntax. So what it looks like when you write Markdown, you have these kind of code, inline code blocks, and before it, now you have a name essentially of how it's going to be interpreted, and the same for admonitions. And you see they're all nicely syntax highlighted here in VS Code. You can hover over them. You can auto complete based on ones that are available. And this is all within this missed Markdown extension. And also, if you click on the preview, you'll get some of them actually aren't done because it's a older version. It turns these admonitions into their kind of final format, their rendered format. So you see here we have a note nested in a note. We have a figure here with a caption, this list format for tables, etc. Now, also, as well as being an extended Markdown format, this document is also a notebook in a slightly different format. So if you look at the top here, you might have noticed it has all this metadata, this front matter, and this tells Jupyter text, which you may have heard of, how to convert this into a notebook. And so you'll see, for instance, these this plus syntax tells Jupyter text that this is starting a new Markdown cell, and then we have code cells and we have raw cells. So if we now go over to Jupyter Lab with the Jupyter text extension installed, we can open up this Markdown as a notebook, and we get a lovely notebook. And also with the Jupyter Lab Mist extension, we also have all of our nice rendering of all the Markdown cells. So, you know, you can change these, they look like that. And yeah, when you execute it, you get all of your rendering of all your HTML. And so obviously very much like how the end product of your book will look like. And here, for instance, yeah, we've got the cell tags that it's captured, and we have our code cells to run. So that's the first step, really. So this is all built on Markdown.net, which is a Markdown parser that's very extensible, and within that we've written a number of plugin extensions, and they all run together, so you get this consistent approach over VS Code and over Jupyter Lab. Also, we're collaborating with some other guys on CurveNote, which is another kind of scientific writing platform that also uses Miss Markdown. So yeah, that's all nice. So it's nice now that you can properly see what you're actually writing with this Miss Markdown. It doesn't just look like raw text. You can properly have all of these nice roles and directives. Then quickly, the other thing, so with these Markdown text-based formats, kind of one of the problems is obviously that they don't store the code cell outputs. Now this is nice. These, you know, the text-based formats are nice for saving in Git, having on GitHub and seeing all of you, or having nice diffs and things, and having a nice editor experience. But they're not, great for that, for saving the notebooks. So this is where Jupyter Cache comes in. And the idea of Jupyter Cache, which is integrated into JupyterBook and MistMB, is that you can have a project. So you have all of your notebooks within the project, and it knows how to read them. And what it does is it essentially it caches the execution. So after you've executed your notebooks, it stores them within this cache. It stores all the outputs. And one of the nice things about it as well is that it knows whether a code has changed and it needs to be re-executed, or it's just markdown, which doesn't need to be executed. So if I type in something here, you'll see that when I list it, it's still saying, it's still nice and green and saying, okay, that's fine. If I change this, then it's now saying, I've no longer got that notebook cached because it's got it will have a different execution. So if I execute the project now, it will look down what notebooks need to be executed and execute only them ones and cache them again. So this is a way that we can have these markdown format, these text-based format executions, or you can even run this with notebooks. If you have lots of notebooks and you want to know, I want to keep them up to date, I want to make sure they're all executed, but I don't have to open them all and execute them separately and things. So this is how we do this for Jupyter Cache. And the last thing I wanted to just touch on is the kind of how do you take these notebooks. So we have these kind of preview formats within JupyterLab and VS Code. We also want to eventually create a final kind of representation, either in HTML or LaTeX or any other format. So with MistMB, what I've been working on is kind of having a simpler, being able to have a simpler standalone CLI for converting them to other formats, say like HTML or LaTeX. This is somewhat, it's kind of similar to MB Convert, which you may well have heard of, but different to MB Convert, it hooks into DocuTils, which is the underlying package behind Sphinx and things like this. So you get these really rich features for creating documentation. So for instance, if I do this, it's firstly going to execute the notebook, so it's going to set it up, and then it's converting it to this DocuTils AST format where it knows what to do with it. Or, we can run this straight with HTML and get out our HTML output. So again, I haven't got it linked into Jupyter Cache at the moment, but you can also do that. So we get it out that way. Cool. I think that's the main things I wanted to say. There's a quick rundown of what we've been playing around with. Any questions?
Not a question, but just a comment. Maybe it was just me when you opened that something with a file extension .md and it showed the notebook icon. That was a real ride for me. That made me laugh really hard. Thank you.
It just this is all good work by Jupyter and being able to do this. And you can have these linked. You can have synced notebooks and markdown formats and all this good stuff. But yeah, I certainly tell you to go and check out that project.
So I'm curious, Chris, how if Angus's Jupyter markup work informed any of this stuff for you, and if there's a way
I definitely give a shout out to I said I would give that shout out to him, but I completely forgot. So this all builds on Angus's. I did tell him I was doing this for him to pop in, but I don't think he said. This builds on Angus's markdown here, JupyterLab markup tool.
So is that a dependency of your project, or is it in JupyterLab markup?
No, so what JupyterLab markup is does very much actually what VS Code's markdown implementation does, which starts up this markdown for Markdown parser creates a kind of instance of that, and then allows you to add plugins to it.
Yeah.
So this how you add tables and roles and these directives and everything like this. So we plug into that. So essentially, we take Angus's Jupyter Lab markup, and we say, here's some extra plugins for you. Here's which say how to pass them, and also, you know, how to convert them out into HTML and with the CSS and everything.
Very cool, man. Yeah, the Jupyter Lab markup extension's like one of the best I feel like everybody should just have it. And also GitHub on their roadmap has like mermaid diagrams and some of the features that are in Jupyter Lab markup. But between Jupyter Lab markup and what you've demoed here, like it's starting to really see like a really rocking document editing platform and coding platform.
Exactly. That's the hope. Yeah, that you get all of this lovely, you know, the kernels and everything you get with Jupyter, but also this rich markdown environment. And yeah, there's a lot of talk over in this Jupyter Lab markup about how we can extend that and improve that with like syntax highlighting, and also kind of the LSP features. As I say, within the VS Code, I've started to add these kind of LSP features where you get like the auto completion and the hover over to be able to write these. That's not currently within the Jupyter Lab extension, but I'd certainly like to look into that. There's the Jupyter Lab LSP, so we're hoping to kind of work with them, with those guys, to do that as well.
So, Chris, a question on the cache, Jupyter Cache. So this is for preserving the output of the execution, the state of the notebook, right? Which includes the outputs or anything that your code produces. Is that right?
Yes. So the idea is that it essentially hashes your notebook, looks at just kind of ignores any of the markdown and just looks at the code and you know the metadata for the kernel and things like that, and says, has any of that changed since I last executed? And if it doesn't, then that's fine. It says, okay, here's and links that. So it hashes your notebook in terms of the code cells and the code metadata, and then links that to something that it's already executed. And if not, then it has the mechanisms in there via MB client, which is another good project that people are working on, which is essentially taking what was in MB convert and kind of making it its own standalone project, and how you execute notebooks outside of Jupyter Lab or Jupyter Notebook, just via the CLI and things. But yeah, that's the idea, is that it just has a cache of everything that's executed.
Yeah, actually, I noticed the parallels that, because I was talking about recording everything in MLflow kernel with versioned outputs like every step. So Jupyter Cache is something that records locally, and it has some additional features. But if it is integrated with, say, MLflow in the backend, then actually we could have a version recording. We can go back to previous versions, but I mean, there'll be some integration work needed.
I'd certainly be interested to hear from that. I say, yeah, that our main focus on kind of Jupyter Cache was obviously how can you create books and things where you don't want to, every time you change a line of your documentation, it has to, you know, re-execute everything every time. So it's that kind of thing that we're after, but it can certainly be extended to things like this, like versioning.
I believe Zach raised his hand.
Yeah.
Okay.
This is super sweet, Chris. Thanks for doing this demo. This
has it lived up to your expectation?
Oh yeah, for sure. I wanted to, this is more of a comment. A couple summers ago, Isabella knows this all too well. Some of the interns at Cal Poly worked on a front-end extension to basically provide like a what you see is what you get, a WYSIWYG editor in Markdown cells in Jupyter Lab. One of the challenges of that was, like, when you wanted to do something more complex, like add a note or something like that, or something that isn't in the standard Markdown, like you were limited by what Markdown could do. I see this as being like way more powerful for something like that, where you can have, you have a markup set of syntax that you can build an editor that allows you to just automatically populate that down into the markdown, but show it as a WYSIWYG. And
yeah, certainly
for that.
Yeah, and I'd say I was just going on to this. I'd certainly give a shout out to the Curve Note folks that we're working with quite a bit. They're working on this site, the Curve Note, which has these more kind of, I guess, richer, almost WYSIWYG features, where I guess you are more with the Jupyter Lab Mist extension. Obviously, you're writing within standard Markdown. Then once you execute, you kind of render, then you click, your shift tab or whatever it's, shift enter, to render the cell. The Curve Note folks are working on this more kind of integrated way of doing it as well, where you are doing that, the full kind of what you see is what you get approach. But again, it's all, the idea is that it all kind of flows from the same base code. The bottom end, we reuse as much as possible.
I love this. The most inclusive future is that everybody just programs in Markdown. No Python versus Java wars anymore. Everybody just programs in Markdown. So write a program as a story. It'll be great.
That's the dream. Cool. Well, I'll stop sharing.
Yeah, that was, those were both really cool. That was interesting too, seeing a little bit of synchronicity at the end there with some related tools.
Hopefully we can continue that, yeah.
No, right, but that makes me so happy, right, that we can, it's arguably one of the points of community calls, so just nice to see it happen. But yeah,
I see Nick Bolwick, is it? Yeah, he's obviously, I was saying about Jupyter Lab LSP and things. It's the big proponent of that, I guess.
Yeah, I was also just skimming the chat to make sure we didn't miss any questions. But yeah, we definitely have a few minutes left for any more thoughts on either share or final exciting things. And I'll be quiet for a few moments for y'all to stew on that.
Yeah, I mean, there's been a lot of discussion over time about a bunch of these features, and it gets to the end of it of who decides what is the Markdown. And if we're just some other folks, it's not a reference implementation in Perl, but it's these reference implementations in these two environments. It's inclusive if you're in the game, right? And I want to make sure that we're not creating, some new thing that is now this other language specification, and you got to be running these 6 versions of, Jupytext and all this other stuff. And I don't know, if there's not a way to describe what these extensions are that you're having, then you're going to run into all these same problems that we have with magics inside of Python and magics inside of derivative kernels and stuff like that. So I hope at some point we do have a Jupyter Lab markup, that is, or a Jupyter-wide markup that is described in such a way that we can use it in a bunch of places confidently. And if they change, migrate them, Everybody poo-poos on the notebook format, but gosh darn it, if that thing doesn't take care of itself, right? It's one of the few self-healing formats out there. I just don't want to lose that for, whatever gains we're getting. Also on the MLflow one, have you guys looked into kernel, the enterprise kernel gateway? It seems like if you wrapped it there, where you can intercept all of the kernel messages, then you could instantly have this for, every kernel, and it wouldn't just be Python. You could have the Scala kernels, and you could have the Spark kernels, and you could have the Julia kernels. Oh
yeah, okay, that's a good point. Yeah, I will look into it. I did some experimentations with kernel gateway, and because we want to be able to basically somehow work with different kernels, particularly not for the reason of different languages, but for like different kind of hardware. If you have different kernels, one running in with GPUs, one running on some CPUs, and have some ability to multiplex between them, that kind of direction we were thinking of, but that makes a lot of sense. We can have an MLflow kernel for all the languages. That would be interesting.
That sounds really cool, actually. I think say that.
Yeah, no, I just as we speak, I'm working on a kind of mist. We're trying to work on like a mist specification and things, and these kind of things to make things more regimented, I guess, more standardized.
Quarto did a good job of that, right? Where they took the common mark spec and then they wrote their own specification over top of it. Or you go into that level of detail, Chris?
So I've started writing this a format called Unist, and then there's MDAST on top of it. It's essentially just a JSON format for common mark, extensible JSON format. That Remark uses is a Jupyter package, but that's what I'm writing because I think it basically has what we need. It's JSONable, so it's language agnostic, and it captures all the information like position and things like of all the syntax stuff that we need for like LSP stuff, like where is something in a document and things. So that's the idea, to kind of build on that. That has the common mark, and then they also, I mean, they have there already like a common mark and then a GitHub flavored markdown extension over that, and then the idea is that we have a missed one.
Does R Markdown do something like this? Because it seems you guys are mimicking R Markdown syntax in some way, right?
I mean, obviously, I guess, I mean, there's certainly read across. It was, I mean, obviously it was more coming from the level of how can we get all the features of restructured text, really, rather than looking at our markdown specifically. But they're very similar, obviously, concerns of how do we get these kind of extensibility within markdown, I guess, of the directives and the roles and things. So certainly been looking at it, but there's a lot of read across in all of these, and hopefully we can converge on something.
Nice. Congrats on making boring work look cool.
It's fun if you sound like me. But
Wonderful. We are approaching time. I don't want to cut anyone off though. So any last things? If not, I will be linking. Okay, then I am going to link you all to our little feedback form in case you have any thoughts. This is mostly, I do read these to make sure nothing goes wrong with the recordings, audio quality, and just if you have any ideas for us. And it's a really not pretty Google link, but if you have any comments on this call you want to give, you can give it there. We will also have our next community call in February, if I can find the agenda. I believe it's the 22nd, same Zoom time, same Zoom channel. And you can already sign up if you're so excited, so inspired by today. We do have the agenda for next month there, totally open, just making sure people know you can share anything Jupyter related that you want. It's just a big show and tell where we get excited. So thank you so much for all your time. This was a really fun call, a great way to kick off the year and still kind of early week. So thank you so much.
Thank you.
Thank you.
Thanks, Isabella. Thanks you all.